In this video we're going to see some applications of the compound angle formulae that we derived in the last video. Okay, let's see if we can prove this identity. So what we've got here is a compound angle in terms of 3a, and we're trying to show that it equals this expression here. Now usually, but not always, the easiest thing to do is if you've got a compound angle is to split that one up. So if we consider the left hand side like that, and we end up with that equals sine of 2a plus a for this one here. So this is like our sine a plus b that we looked at in the first video, and we can expand that using the normal formula. Now when we've got this, we've got something that's not quite like this yet. We've got the sine 2a cos a sine a cos 2a, but there are no double angle formulas in this expression, so we need to expand those, and we can use these expressions here, which we can either look in our formula book or we can really understand from the first video if we make it a plus a rather than a plus b. Now what we've got to do is substitute these into here and here for the correct expression. So now we've got this one. Now we've got a bracket, there are no brackets here, so it makes sense to expand these. So you can see here we're going to get the cos squared, from here we're going to get the sine cos squared. So we get this expression. So this is two of them, this is one of them, join them together and we've got 3 sine a cos squared a minus sine cubed a. So they're identical. There we go, all proved. Okay, let's look at another identity. Now I said previously that probably the easiest thing to do would be to expand this one here, and you certainly could do that, but actually in this case my choice would be to write this one here by bringing the sec squared up as a cos squared to give us 1 minus tan squared cos squared. Now we know that tan squared is the same as sine squared over cos squared, so that's going to give us 1 times cos squared is cos squared, and tan squared times cos squared is sine squared. And if we look in our formula books, we can see that cos squared minus sine squared equals cos 2x, so there we've proved it again. Another thing we can do with our compound angles is find some more exact values. We learnt in a previous video how to find the exact values of 30 degrees, 45 degrees and 60 degrees. What if we wanted something like 15 degrees? Well, we can just use the fact that 15 is the same as 60 minus 45, and we know those angles already. And we can use our compound angle formulae to get this one here, and then we can just substitute 60 for A and 45 for B. So when we've got that angle there, those angles there, we can put them in. We know these answers and we can just substitute for them, and we get root 3 minus 1 over 1 plus root 3. And obviously that's not in the correct form that we want, so if we just multiply the top and bottom by 1 minus root 3, we get 2 minus root 3 for that exact value. In the description below you can find a link to a worksheet that has questions that you can try on your own. I hope you found this video helpful. Stay in field with Winfield.